Okay, so on the homework number 1, we're finding the inverse. Well, you know, this guy says log, right? And when I think log, okay, this little base number, it comes down, yeah? And this x and the y, they switch when you move it to exponential form, all right? So x goes on the other side here, and this y goes on that side. All right, does that make sense? Okay, and then you're finding the inverse, so then just switch your x and your y, so now you have 9 to the x equals y. There. Oh yeah, no, that's all you're doing. That's all you're doing when you find the inverse. Okay? Yeah, the 2's the same way. What is the, yeah, it's right now it's an exponential, so you gotta write it as a log, right? E is the base for not log log, but ln log. Do you agree? Okay. Base of E, I'm not going to write that, right? Y equals X. Yeah? Okay. So then now find the inverse, just switch your X and your Y. So ln of X equals Y, a little inverse. There you go. Right? Alright, and to be honest with you, I do this whole other cheesy thing when I... Okay, so let's talk about exponential equations, okay? Now we're solving. And you know you're solving because equations have a what sign?
Equal.
Equal sign, good. When you see an equal sign, that's when you're solving. So, you're going to have a bunch of different scenarios for this. So the first scenario is you have an exponential on one side of the equation. All right, so when that happens, you want to get the exponential by itself. Rewrite it into log form. And then change your log into a number, which means you're going to evaluate, and then you're going to solve for x, right? And here is probably where you're going to do your biggie smalls. All right, your change of base. Okay? Sorry, it's just the words. But when you see the type of problems, it'll make more sense. Yeah, well, so if it looks like this and you can't just think of, oh, what can I plug into x? Like, these are all going to be a little bit weird, right? We need to change it to the other form, all right? When in doubt, you get stuck, change it to the other form, and it might make more sense. So if you look at this, number 1, okay, I have my exponential right there, 2 to the x. Get that all by itself. Subtract that 1. So now you have 2 to the x equals 4. Yeah, so this is pretty easy because you can say, wait a minute, 2 to the what power equals 4?
2.
Yeah. All right.
So it's not good to just divide it by 2, right?
No, you can't divide it because that's an exponent.
I just wanted to make sure.
All right. So that's it.
I thought we were supposed to move it into log form.
I mean, you can, but this we can figure out, right? Change it to log form if you can't figure it out. Okay? We'll have another example of that. Okay? So let's look at this. My exponential is that guy. I don't need to move anything. This is already ready to go. So this one's not, I can't figure this out. 10 to the something power minus 10 to the something minus 3 power equals 4. Change to log form. So log, wait a minute, if my base is 10, do I have to write that 10? No, it's common log, right? Answer equals exponent. Yeah? So look at this. So good. If I want to solve for this x, all I have to do is add the 3, right? But be careful here and watch what I'm doing very carefully. Log of 4, okay? That was there first. It's not log 4 plus 3. It's log of 4 and then plus 3. See what I'm saying? It's not log of 7. Yes?
And then we put
So,
all of that
yeah.
in.
Now let's put it into the calculator. That was pretty easy. I'm going to do log of 4, right? Plus 3.
That's a decimal.
Good. You can get a decimal. Let's round it to 3 decimal places. 3.602, right? All right, good. This. Okay, so x equals 3.602. Okay, questions? All right.
So when you have 10 as your base, that's when
That is the
that's
given
common law. So
for
you have-
LOG. You don't have to write it. So look at number 3. Guys, what is the exponential here?
X, it's the E.
It's the E. Oh no. So you got to get rid of that 2. How do you get rid of this 2? Divide. Good. So then you have e to the x plus 1 equals 2. Can't figure that one out. Just, right? That was not an easy one. So change this to log form. What kind of log do I get when my base is e?
ln.
ln. Base answer equals exponent. Yeah? Again, guys, this is the same thing. It's ln of 2. You need to subtract the 1, right? ln of 2 minus 1 gives you x. So what is that?
Negative 0.307.
Oh. Okay, so negative 0.307. Thank you.
3 what?
X equals negative 0.307. Huh?
Never mind.
Okay, so next one. All right, so that was one scenario. The second one is you have an exponential on both sides of the equation. Now you have 2 of them. All right. So what you need to do is you have to make the bases of your exponentials equal to each other. Okay? So they both have to have the same base. And then you can set your exponents equal to each other. If they have the same base, it's like you could just drop the base and make those exponents equal. All right? Because that base, if they're the same, they're not going to affect anything. And then solve for x. All right, let's try it. So look at number 1. What are your bases?
36.
10.
10. They're already the same, right? So, you know what? You can drop the base and then set your exponents equal to each other. You can only drop the base if your bases are the same. And then just solve. All right? So what is this? I'm going to subtract 2x.
X equals
I'm
negative
going to
1.
add the 1. So what is this? Negative 2 equals 2x. X equals negative 1.
Yes.
All right, good. Perfect. Are we okay with that? I did it in 2 steps. You know what? I'm sorry. I could do this one in a different color. That helps. Okay. All right, so let's look at number 2. Number 2. So I have a 2 as my base on the left. And wait a minute. An 8 as my base on the right. So you can't do that. You got to make these exponents. Okay, so you have to make the bases the same. So think about this. Rule of thumb, don't try to manipulate your smaller one. You're going to have to rewrite your bigger one, okay? So you have to think to yourself, okay, I have 2 to the 4x. So now that 8, let's think about 8. Is there any way that I can get 2 to be the base and make it like 2 to the something power so that I can get 8? 3. That's how you make the bases the same. Okay, you can't just say, oh, I'm going to multiply it by 4. No, right? Because we need to change the base to an exponent. So, Yule said 3. Good. 2 cubed gives you 8. So now this 8, we're going to rewrite it as 2 cubed. But guys, what was already there with the 8? X minus 2. So you know what? We just have to multiply that with that new 3. Does this make sense?
So basically, it's whatever, smaller number, like whatever you get to get your bigger number.
You're probably going to match, unless you get like a 8 and 16. Then you're going to have to make both of them base 2. Do you know what I mean? But we wouldn't make it like really crazy. Oh, okay, so the next one. Okay, well, there we go. All right, well, let's drop the base. Hold on to that thought, Isaiah, okay? You'll see it. So then this one would be 4x equals. Good, you gotta distribute. 4x equals 3x minus 6. Good. Subtract that 3x and you get x equals negative 6. All right? Questions so far? Are we okay? We're doing a really good job. All right. Let's look at the next one then. Okay, so this next one, so you have a 9 and you have a 27. Okay, you got to think about this. All right? 9 and 27. Well, you know what? If I have nowhere to start, I'm going to think, okay, what do I get if I have 9 squared? 81. So I can't think about changing my 27 to have a base of 9, right? So in this case, you actually have to change both of the bases.
3 squared and 3 cubed.
Yeah, 9 and 27, they have a common base. It's 3. Okay? 9 equals 3 to the what?
Second.
Yeah, 3 squared. And 27
3
equals
cubed.
3 to the what?
Cubed.
Cubed. But you see how both of those had exponents before? You got to bring those guys down. So x plus 1 on the left and x minus 1 on the right. Does this make sense? So you may want to brush up on maybe your perfect squares and your perfect cubes. That'll be a fun little activity to do.
Wait, which one are you on?
Cubes. Alright, so anyway, you drop the base. You have 2x plus 2 equals 3x minus 3. I'm not going to rewrite it and then distribute. We're at a point now where we can just go straight to distributing, right? If we solve this, I'm going to subtract the 2x. 2 equals x minus 3. Add the 3, so we get x equals 5. Do you agree?
Yes.
All right, good. Great job. With the exponentials, we don't have to check. All right? Do you know why? Why do I not need to check and see if maybe this x doesn't work here? Think about the graph for exponentials. What is the domain?
Negative to infinity.
Negative infinity to infinity. Doesn't that mean that all real values work for x, right? So, you know what? Exponentials, you're good. You don't need to check, okay? But what do you do if you get stuck? Oh, what is this? If you are not able to convert to the same base or just want to check the answer, solve it by graphing.
Is the thingy still recording you?
Yep. You can solve it by graphing. So that 9, the base of 9 to the x plus 1 power equals 27 to the x minus 1 power. Say I couldn't come up with, they both have a base of 3, right? Okay, well then you can just graph it. Put into your y equals, into y1, you can put in 3 to the, no, it wasn't 3, what was it, 9? It was 9 to the x plus 1.
Mhm.
And in your y2, you can put 27 to the x minus 1, go to graph, and then find your point of intersection, okay? Second trace, intersect, and then look for where they intersect each other, and you can find your solutions that way too. Should be at 5. X number 5, Y number something else. All right? So this is just, you know, for you to know. We will try that method if we get stuck. Okay? So let's try these. All right, so 4 to the x plus 1 equals 3 to the x minus 1. Right? All right, so with this, you want to try graphing this? All right. So then into y1, let's put in 4 to the x plus 1. Do you see how I'm putting the x plus 1 in parentheses? Because all of it is in the exponent. And then y sub 2, I'm going to put in 3 to the x minus 1. Now, I'm going to go to my y equals. I'm going to put 4 to the x plus 1. 3 to the x minus 1. Those are correct, right?
Yeah.
Okay.
Okay, good.
All right.
Okay.
Okay, that's okay.
How do you know?
So you should have 2 exponentials growth, right?
Then how do we know when it intersects?
All right. I mean, it's going to be like here, right? It might be around like this -3, -4 area, or x equals -3, -4 area. So second trace, let's go to intersect. Don't use the up down, okay? Use left right. And you know what? I'm actually going to move my blinking bob just a little bit closer towards the asymptote. I'm going to hit enter. Yeah?
You won't like do
Oh, go to second trace intersect. And then for the second one, your calculator will automatically take you to the y sub 2. So you should just be able to hit enter. When it says guess, hit enter again. See if it works. Negative 8.637 or 8.
8.
8. Did you get it?
my calculator.
So, all right. And your calculator will actually take you right over to that intersection. So x equals negative 8.638. All right. So guys, try the next one, please. You should be able to do this one by changing them into the same base. So this one should be, did you change them both to have a base of 3? Good. So this one should be 3 squared for the 9 and 3 cubed for the 27, yes? Okay. Now the bases are the same, so drop the base. 2x plus 2 equals 3x minus 3. Listen, I am not writing it over and drawing my arrows because I have been distributing for a long time. If you forget to distribute either to that second term or whatever, please draw your arrows, okay? Don't get this wrong because you forget to distribute. That would be a waste. Yes. Is that the same problem?
You're struggling on the test, finding the eight, the something, and you're looking at 9 and have no idea. So center is the calculator and is.
Sorry, after I I was like, wait a minute, this seems so familiar. It's exactly the same problem. Sorry. Do you guys want to do the next one in the calculator as
It's
a graphing?
No, it's the same one as up there too.
Okay, good.
You do everyone graphing?
You can.
Oh, really?
But if you can do it this way, show your work. Okay? So if you put it in the calculator and you do it wrong, then there's no way for us to give you some partial credit somewhere. All right, what about this?
X equals 2.
Yeah. So 2 to the x equals 4, right?
Yes.
Okay. So, all right, let's graph this. Let's try this with graphic because that's what I should have done for the one before. Sorry. Oh, you can put this whole thing? Oh, gosh. It just feels so unnatural. All right, so if I were to graph this, and actually this is a really good one because we don't have another equation, we just have a regular old 4, right? So if I graph this, a lot of you guys are like, well, I got 2. All right, that's fine. Let's check it. See, right there, that intersection, that's where I get my x answer from. So second trace intersect. I can move my blinking bob a little bit closer, hit enter again, enter. There you go, x equals 2. Good job. Okay? Yep, 2 to the x. Yep, in the first one, and then I put in 4 in the next one. But you know what? So this is what Miss R was saying. You could put 2 to the x plus 1 into your y sub 1, and then put in 5 into the other one too. That one works. Very good. Questions? All right, let's go on to the next. Now we're talking about log equations. You ready?
No.
Yes. All right. So here's the thing. You have to look out for extraneous solutions. As you cannot have negative values or 0 inside logs. You can't have a negative and you can't have a 0 inside logs. So our first scenario with log equations is if you have one logarithm. Okay, so get the log all by itself. Change it to exponential form, then solve it for x. And lastly, you want to check to make sure that the answer is not extraneous. Remember, make a note if you need to. Can't be 0, can't be a negative inside the log. I'll show you what that is, okay? All right. So let's take a look at number 1. All right, so I have, oh my goodness. All right, so
Now you all want to know.
Yeah, what was
it's
it?
not even just asking. Okay, so we have one log. There's a log all by itself on one side.
Yeah.
Yeah. Okay. So change it to exponential form. Base, right? Base answer equals exponent. So base answer equals exponent. Yeah. Rewrite it.
Why is there big space in between those two?
I mean, it's just because they're just far apart. There. Okay? And it's the same thing. Alright. So what is 3 squared? 9. X plus 10.
X equals 9.
Minus the 10. So x equals -1, right? So let's check. All right? So don't forget that you need to check, and this is how you check, okay? You gotta plug it into your parentheses. All right?
Log form.
Yeah, just right after your log, put it into that parentheses. Put it into that x there. -1 plus 10. What is -1 plus 10?
9.
9. Is that a negative? Is that 0?
No.
No. So this one works.
It's a yes from me.
Yeah, this is a yes. And so we could even put it in a solution set to show that, yes, it is a solution. Does that make sense? Okay. Let's try the next one. Log of x. Guys, that is your log. You got to get that all by itself. So what do I need to do?
Split by 2.
Minus the 2. So now you have log of x equals 1. All right. Log of x,
Yeah, I'm not
because it's not in parentheses. Right? Yeah, because it's not in parentheses with the x. Okay? So, all right, rewrite this. Base 10 exponent equals x. Right?
Yeah, 10 to the first is just 10.
Yeah, 10 to the first is just 10. So there you go. 10 equals x. Now let's check. Well, you know, you can only plug it in right there. There is no parentheses with the x. It's just x, right?
It's a yes
So
from
if
me.
you plug in a 10 into there, is that a negative? Is that a
I
0?
got 1.
Well, that works. What do you mean you got 1?
My answer when I put that in, I got 1.
Yeah, because you plugged it in here, but look at where I'm plugging it. Are you, look,
I
make sure you
plugged
follow
it
me.
into the log with the exit. I put it there.
I know, but you're just plugging it in here and seeing if that gives you a 0 or a negative. That's why here we only plugged it into the x plus 10. Does that give me a 0 or a negative?
Oh.
All right? Stay with us. Focus, yeah?
Okay.
All right. All right, let's try the next one. So the next one, where is my log?
Log x plus 5.
It's that guy. Log base 2 of x minus 5. So what do I need to do with that 2?
Divide by 2.
Divided by 2, yes. So log base 2 of x minus 5 equals 2. Right? Now, rewrite it.
2 squared equals x minus 5.
2, yep, that's base answer equals exponent. So 2 squared equals x minus 5. What is 2 squared?
4.
4.
X equals 9.
So 9 is your x. Now you have to check.
I think it,
It's a yes from me.
Plug it into that parentheses with the x, right? So x minus 5. So 9 minus 5, does that give me a 0? Does that give me a negative?
No.
So this one works. Good. You guys are doing a really good job. Is it making sense?
Yes.
Good. If it does not make sense, then please say something. Okay? This is your last new lesson before the test. All right, so how about this? You have 2 logarithms, all right? One on each side of the equal sign, same base, nothing else. All right. So you want to set the logs equal to each other. Solve for x. And then check that the answers are not extraneous. Right? Remember, can't equal 0, can't equal negative. Okay, we're making notes for ourselves. All right. Okay, so let's try this. Okay? No, you're not doing that. What? Were you on your phone? Alright, so when you have logs on both sides, you know what you do? Make sure that the logs are on the opposite sides, okay? And then, you see how those are the same? Drop them. And then you can make those inside the parentheses equal to each other, and then just solve for x. What is that? Minus 2x here, minus the 1 there. 2x equals negative 4.
X equals -2.
Good. X equals -2. Please don't forget to check.
It's a no from me.
That's a no from you. Uh-oh. Let's see. Plug it in here. Plug it in there. See if you get a 0 or a negative.
4 times -2 is -8 plus 1
4
is
times
-7.
-2 plus 1. That is a -8 plus 1. Gives me a -7. Okay, you know what? It's a no. So then this one is a no solution because you only had the one solution, turned out to be extraneous, so you really don't have any solutions, right? All right. Look at the next one. What? Because I plugged it in here and it gave me a negative. You can't get a negative, you can't get a 0. So look at number 2. Guys, these logs, do they have the same base?
Yes.
Yeah. Then are they on opposite sides of the equal sign? All right, drop them. Solve. Negative 3x plus 8 equals x squared minus 20. Ava, you can leave whenever you have to, okay? So you see how there's an x squared, you see how there's an x? How do you solve this?
Factor.
Yes.
No.
Make it equal to 0. This is a trinomial. You need the factor and do the mini equations. Plus 3x minus 8. So then you have 0 equals x squared plus 3x minus 28. AM factor. So then that gives me what? What are two numbers that multiply?
-7 and 7 and -4.
Yep. Okay. So then now, since you have two factors that are equal to 0, you need to make both of them equal to 0 and solve for each of the x's. So mini equations, right? X plus 7 equals 0. X minus 4 equals 0. So you have x equals -7. And you have x equals 4. Bye. Okay? Now, since you have two solutions, possible solutions, it means that you have two that you need to check for. So check this, please. So if I plug in -7 into either one of those, let me see. -7, that's positive, 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 positive. This one works, yeah?
4 does not.
Hmm?
7, -7
So this one
does.
works?
4 does not.
4, let's see. -12 plus 8. Oh, that's a negative. Nope. So, -7. Do you guys see what I'm doing? You need to put it back into the parentheses, right? After log. And if it equals a 0 or a negative number, it is not a solution. All right, so let's try the next one. Guys, what do I do with those two logs? Drop them. Bless you. So you have 4x plus 2, okay, equals x squared minus 19. How do I solve this? Yeah, need a factor, right? So subtract that 4x, subtract the 2. 0 equals x squared minus 4x minus 21. Is AM. Two numbers that multiply to give me negative 21 and adds to give me negative 4.
Negative 7 and 3.
Negative 7 and 3. So x minus 7, x plus 3. Oh, my handwriting is really messy around that. All right, now mini equations, because both of those factors are equal to 0. So x equals 7 here, and x equals negative 3 here. Now let's check and make sure that when I go and plug it back into my log, I don't get a negative or a 0. So 7, when I plug it back in, 7 works, right? How about negative 3?
That's a no for me.
That's a no, yeah. So x equals 7. Yeah? All right, so how about just anything outside of the ordinary? Okay, so like a different base, constants outside of the log, etc. All right, so then with this one, we would solve by what, graphing? Oh my god, is that what? Oh my goodness, so Mrs. R threw us a curveball here. I was like, what am I doing? Solve by graphing, if it looks weird, right? So let's look at number 1. Guys, I have a log on this side and an ln natural log on the other side. Are they the same log? Same base? No, so you can't drop the logs. And this is really weird. I can't do anything else with it, so I'm going to graph. Y sub 1, I'm going to put log of 2x. Y sub 2, I'm going to put ln of x. Let's find the intersections. And let's find our equation, our solution, sorry. Well, I'm looking for x, right? Log of 2x close. Uh-oh. This one is ln of x. All right, so now let's graph it. And you guys should all try this. It's a good, really good tool. Oh, there's a nice little intersection right there. So let's go to second graph. Oh no, so I'm sorry, second trace. Sorry, intersect. Now where's my blinking bob?
Neverland, apparently.
There we go. So I don't want to be right on the intersection. I just want to be a little bit away from it. So like right there. Hit enter again, and then hit enter. 1.703. X equals 1.703. Now you have to check it because it says log, right? So if you plug this into that x, do you get a 0 or a negative? No, so this one is a solution. You know what, I'm just going to draw a little braces around it. Okay? Alright, so let's look at number 2. Whoa. Log base 3 of 3x equals log of x. You know what, I'm going to show you how to put these guys into your calculator to graph it when you have a base there. So in y sub 1, you know, on your left side, this, you're going to put it into your y sub 1 as the change of base formula, okay? So as that biggie smalls thing. So you're going to say log of 3x divided by log of 3. Okay, nope, Isaiah. Nope, absolutely not. Log of x in your y sub 2. And what are your intersections?
X equals 1.22.
All right, well, let's figure it out. And you know, actually, this is very important. If there's a small number base, there's no way for you to like just put it in. You got to put the change of base formula, okay? Log of, what was it?
3x
Mm-hmm.
divided by log of 3.
Of 3. Oh, no.
Log of 3.
Sorry. Log of 3. And the other one is log of 3?
Log of x.
Oh, God. So off. All right. Okay, so it looks like the intersection is like right there where it starts meeting the well, it starts getting closer to the asymptote. So second trace intersect. All right, just get really close to it. So like right there, hit enter, enter, enter. There you go. 0.122.
2.
Good. X equals 0.122. Is this a solution?
Yes or no?
No.
Yeah, because if you plug it into those x's, do you get a negative or a 0? No. So, this, I'm going to say yes. I'll even put a little check. There we
Say
go.
yes for me.
Good. Do we have any other sections after this? Just practice problems, right? Make sure you guys bring these notes to the next class, okay? We are going to finish all those practice problems. That one, you can put it into the calculator. Good.